Welcome to the Q&A session 13 from the playlist of electromagnetic induction. The topic is the induced EMF due to the mutual inductance. And this session is in continuation of the session number 12, in which we have studied about the mutual inductance of a pair of two coils. And we have also studied about the coupling coefficient, or you can say the coefficient of coupling. So based on the session number 12, I have selected one question for this session, which is written here on this board. And the question is, two coupled coils of self-inductance L1, which is equal to 0.5 Henry, and L2, which is equal to 4 Henry, have the coefficient of coupling equal to 0.8. Now if a current of I, which is equal to 20 sin 314t, is passed in the coil number 1, then the maximum value of the induced EMF in the coil number 2 is. So there are four options here, and we have to find the correct one. So in the previous session, we have learned that the mutual inductance of the two coils is given by M is equal to K under root L1 into L2, and here K is the coupling coefficient, which is equal to 0.8 in this question, multiplied by under root of L1 into L2. So here L1 is equal to 0.5 and L2 here is 4 Henry. So the value of the mutual inductance is equal to 0.8 into under root 2 Henry. Now the current which is passing in the coil number 1 is equal to 20 sin 314t, and we have to find the maximum value of the induced EMF in the coil number 2 when the current I, which is equal to 20 sin 314t, is passed in the coil number 1. So the formula for the induced EMF, as we have learned in the session number 12, is equal to M di upon dt. So this will be equal to M. The value of M, that is the mutual inductance, is equal to 0.8 into root 2 Henry. So I will be putting this value here, that is equal to 0.8 into root 2, and di upon dt will be equal to 20 into, this will be equal to 20 into 314 into cos 314t. So this is the value of the induced EMF in the coil number 2. But we have to find the maximum value of the induced EMF in the coil number 2. So the maximum value of this induced EMF is depending on the value of cos 314t, and the maximum value of the cos, as we know that the maximum value of cos theta is equal to 1. So cos 314t, the maximum value of cos 314t will be equal to 1. So the maximum value of the induced EMF in the coil number 2 will be equal to 0.8 into root 2 into 20 into 314. So this is equal to 0.8 into 1.41 into 20 into 314 volts. So this is equal to, this is approximately equal to this is approximately equal to 7083.84 volts. So the maximum value of the induced EMF in the coil number 2 is equal to 7083.84 volts. But here we have been given four options here. So here we are seeing that in the option number C, that is option number C, the value is equal to 7.1 kilovolt. So If I convert this value in kilovolts, I will be getting the value of E maximum as 7.083 volts, or this is approximately equal to 7.1 kilovolts. So the maximum value of the induced EMF in the coil will be equal to 7.1 kilovolt, and this is the approximate value. So the correct option here will be C. So here in this question we have to use two formulas. The first one is, that is the mutual inductance of the two coupled coils is equal to K under root L1 into L2, and then after finding the value of the mutual inductance, we were supposed to find the value of the induced EMF by using the formula E is equal to m di upon dt. So here we have differentiated the this equation, that is I is equal to 20 sin 314 t with respect to t in order to find the value of di upon dt. After finding this value, we have found the value of the maximum. We have found the maximum value of the induced EMF by putting the value of cos 314 t as equal to 1, because the maximum value of the cos theta is equal to 1. So the maximum value of this cos 314 t will be equal to 1. So by putting this value equal to 1, we have been able to find the maximum value of the induced EMF in the coil number 2, which was approximately equal to 7.1 kilovolt. So thank you very much for joining this session. In the next session, I will be coming up with a different type of a question from the same topic, that is mutual inductance. So till then, have a nice day. Bye.